is Saif Mohammad from the NRC, and Saif will be talking about examining fairness through emotions and language.
Thank you, Michelle. And first of all, it's so exciting to hear those two talks by Graham and Joel. It's super fun. I'll be talking about some of the same threads that were talked about in those two talks, but I'll be talking with a focus on emotions. I've been working on emotions for a few years now, and I find them super fun and interesting. Not the least because, on the one hand, they are very everyday and familiar, but on the other hand, when you try to get a handle on them, they can be surprisingly nuanced and complex. People think that emotions are incredibly pervasive. They determine human experience and behavior. They condition our actions. Some argue that there is no cognition, no thought without emotions. So as I said, for many years I've been focusing on working on emotions, and I use Nemo as my metaphor for emotions because it's a slippery concept. But what I've noted over the years is when you work with emotions, it's hard not to bump into certain other characters. For example, creativity. And that makes a lot of sense because if creative things tend to have an emotional impact, so it's not hard to see that connection. So we've been doing some work on computational creativity, but I'll not be talking about that particularly in this talk. What I will be talking about is the other thing you bump into, which is fairness. And that also makes sense because if you feel differently towards different demographic groups, then that percolates in the language you use and the emotions you express in that language. So I'll start off by talking about some work that we did just last year, where we organized this shared task. This is an international competition in SemiVal. SemiVal is the largest, competition platform for natural language processing. But shared tasks are also pervasive in machine learning and vision. They drive the research forward, where you've got all these people trying to show. You create this new test set, and you ask people to submit their systems, and you see who is better on that same training and test sets and that sort of setup. So we had the shared task on inferring various affectual states of a tweeter given the tweet that they presented. We had data sets in English, Arabic, and Spanish. We had 75 teams that year with 250 systems. This was a record for SemiVal last year. This year we've got some tasks with even more participants. But unlike all of the other tasks at SemiVal that happened before, which largely only focused on can we get better accuracy at this task that I'm interested in, we also added this particular additional evaluation component, which was there to test biases in the system. So we want you to build good systems that can detect emotions in text and in tweets, but we also want to see are they biased in certain ways, and especially this was focused on race and gender. And of course, I don't need to tell that to this audience, but it all arises because of the question, do machines make fair decisions? And the answer really is not always. Recent studies have shown that, especially as systems get more and more sophisticated, these inadvertently, they have inherited certain biases from humans. So, you've got the Microsoft's racist chatbot, you've got the Amazon's recruiting system that Graham mentioned, face recognition systems that do well for white men, but not well for African-American women. You've got this crime recidivism systems that predict whether you'll commit crime again or decide your parole, and those have been shown to be incredibly biased towards African-American people living in African-American neighborhoods. And the reason for this is, as was sort of pointed out earlier as well, because these machines are built on human data, and while we might think that this data is coming from upstanding people from the society, in reality the picture is more like this. You've got decidedly flawed characters. People have faults, everybody has faults. We produce language that has faults, and if computers learn from them, they have faults as well. So here's some more examples of that data thing. Some years back, Google OCR'd, or a gazillion books that were in existence from 1500 to now, and they gave out that data in certain forms so that we can look at language how it has been in such a long time over all these books. Last year, we did a simple search. We looked for occurrences of the words son and daughter in this corpus. And what you see is that the occurrences of son in all these books that we've had is almost twice as much as what has been the case for the occurrences of daughters. There might be good reasons for it. I don't know. But certainly, this is the data that all our kids are being exposed to. So let's take that a little further. What if you search for genius son and genius daughter in this Google Books corpus. The difference becomes even more stark. You see way more occurrences of genius son in these books, genius daughter way less. And we were inspired by this work done by somebody who worked at Google early on, who was looking into Google query logs. What do people search for on Google? And he found things like people search way more, and this is parents, they search way more for, is my son gifted than is my daughter gifted? Is my son intelligent or a genius than is my daughter gifted, intelligent or genius? He also tried to look, okay, so when do people's parents search more in terms of their girls or their daughters? And he found that they do higher frequency searches for their daughters when it comes to appearance. So is my daughter overweight? Then is much more frequent than is my son overweight. And he was giving some interviews later, and he was saying how he already had a pretty cynical view of the world, but when he came across all this, it just became much worse. So coming back to this shared task that we had, that I was telling you about, we wanted to build this sort of evaluation component that has these that tests biases towards race and gender. And so with my colleague Svetlana Kirichenko, who's also here, we developed this corpus. We call this the equity evaluation corpus. It has about 8,000 sentences that have been carefully designed to tease out these biases towards race and gender. And specifically speaking, what they had were pairs of sentences that were identical in all respects, but one word was different. So if one sentence was referring to a male, another sentence was referring to a female, but everything else in the sentence was the same. If one sentence is referring to an African American name, another sentence is referring to a European American name, but other than that, the two sentences are pretty much the same. And so what we wanted to do in the shared task was that take all these sentiment analysis or emotion detection systems that are there to detect emotions accurately and run them on these pairs as well as an additional test set and see if there are they giving the same emotion scores to these two sentences, or are they randomly going here and there, or are they systematically giving consistently more emotion scores towards one race or one gender? And the details are in this paper listed down below, but to sum up, not surprisingly actually, more than 75% of the systems tend to consistently mark sentences involving gender and race with higher intensity scores. So, and these differences fell along standard stereotypical dimensions. So for example, if a sentence mentions an African American person, it is automatically given a slightly more angry score than a sentence that mentions a European American name. If a sentence mentions a female, it's given a slightly more happy or a sadness score than a sentence that measures simply mentions a male reference. And again, the reason is back to the data. This way back in 2011 itself, once again, we were looking at the Google Books corpus and using some of the emotion resources that we had developed at NRC. And we showed that if you look at occurrences of man and woman in all this massive collection of books that we've created as a collective, what we find is the occurrences of man are surrounded by way more angry terms than occurrences of women, and occurrences of women are surrounded by way more joy terms than occurrences of man. Once again, there might be good reasons for this, but let's also be careful that this is the kind of data that is often fed to our systems, and when it is applied willy-nilly to other tasks, it can have inappropriate consequences. So some of the work that we are doing right now, circling back on that way earlier work with one of my students, we are also looking at this more comprehensively and looking at dyadic interactions. So when when women talk to women or about women, when women talk to men or about men, when men talk to men or about men, and so on, what kind of emotional language do they use? Are there systematic differences in the language that they use? And once again, we look at the Google Books corpus because that's the literature that's out there, and also in social media content. The second part I want to talk briefly about is also an issue that was raised earlier, especially by Graham. What about work that can be deliberately abused? And for this, I'll tell you a little story. In 2013, and 14, our NRC team took part in a number of NLP shared task competitions, and we did really well. We came first in a whole number of them. And that had one interesting consequence, was that subsequently a large number of companies came to us and said, hey, we hear you do good sentiment analysis stuff. Why don't you build us a sentiment analysis system? And you know what? Here's my data as well. I've even gone ahead and annotated it with what is positive, negative, and neutral. We're like, wow, that's great, because we always we're hungry for labeled annotated data. But when we look at their annotations, what we find is that out there in the real world, what people are looking for, more often than not, I think, is not whether a tweet is positive, negative, or neutral, not whether it is joy, sadness, or fear expressing. What they're looking for is, does this person, based on this tweet, do they like my product or not? Do they support my presidential candidate or not? Do they like my government policy or not? Are they in favor of it or are they against it? And you can be in favor or against these things, regardless of whether you're saying positive things or negative things. These are orthogonal. So we introduced this new shared task at SemiWell sometime in 2016, where we said, how about this shared task where, given a tweet text and a target that is also predefined, can you infer whether the speaker is in favor of the target, is likely against the target, or whether neither inference is likely? So this is incredibly useful. For example, if you are a government organization and you want to get a sense of what does the population believe in with respect to various issues. So let's say pro-life movement, you have various ways of gathering information for that, but one of the ways is social media. Can I get a handle on what gets more support? What are the issues over here? So given this text and given the tweet, the pregnant are more than walking in incubators and have rights, humans are capable of deducing that a tweeter is likely against this target. However, can we ask machines to do this? That was this task. And this is an incredibly hard task, and we're very happy that a lot of work has been done just in the matter of 2.5 years following the release of that data. However, I did want to point out that, especially in the light of recent events, it is pretty clear that in a world, if you imagine a world where computers can determine your individual stance towards all sorts of issues, that is a dangerous world. It opens the door for abuse and manipulation. There are benefits of this sort of technology when you can use it for an aggregate level to determine policy and other good things, but especially when you try to target individuals, this opens the door for abuse and manipulation. The last point I wanted to talk about was equity does not imply sameness. Right? So we know human cognition, thought, behavior are all impacted by evolutionary and sociocultural factors, right? And these factors impact different demographic groups differently. Consider gender, the male, female, men. Consider the demographic of gender. Men, women, and other genders, we know, are vastly more alike than they are different. However, we also know that over tens of thousands of years, different sociocultural influences have been applied on the different demographic groups, often to exert unequal power status and asymmetric relationships. So one of the goals in gender studies especially is, can we determine the overt and subtle impacts of these sociocultural influences on the different demographic groups? And if you're into language like me, we think about things like, how do different genders perceive and use language? And since, again, I'm particularly within language, I'm interested in emotions, we had an opportunity to look at that question over here. So just to put a little more context to this problem, several earlier influential work looking at how do we capture and represent emotions has identified that there are three core dimensions for emotions, and the valence, arousal, and dominance. Valence is we are familiar with this, is the positive, negative dimension. Arousal is the active, sluggish dimension. Dominance is the powerful, weak, or in control of a situation, or the situation's out of control dimension. So if we want to compare meanings, let's say for words, we can compare them along any of these three dimensions. So for example, we can say banquet indicates more positiveness or higher valence than funeral. Nervous indicates more arousal than lazy. Queen indicates more dominance or power than delicate. So some of the work I did just, again, in the last year was can we obtain reliable ratings of valence, arousal, and dominance for a really large number of sets? 20,000 words, why not? That seems like a good number. And what's more, we've said, humans are capable of pretty fine distinctions when it comes to emotions. So we don't want just 4 or 5 levels of this. We want a really fine-grained distinction with respect to these different categories. And notably, what we did different from much of the past work was we didn't use rating scales, give me a 1, 2, 3 for where this stands. What we did was comparative annotations where we give people 2 or more words and say which is more positive, which is less positive, which has higher arousal. And that eliminated a whole bunch of bias, and we got some really good resources out of it. So this is just a quick sampling. The words with highest and lowest VAD scores. So if you look, for example, love and happy are marked in the lexicon as being the most positive. Toxic and nightmare are words marked as the least positive out of these 20,000 words. Abduction and exorcism, very high arousal. Mellow and siesta, lowest arousal. That makes sense. Powerful and leadership, very dominance. Empty and frail, very weak, very low on dominance. We also did experiments on looking at how reliable these fine-grained annotations are. The details are again in the paper. The correlations with repeat annotations is greater than 0.9, which is really good to have such reliable annotations. So, but of course, coming back to the question that is interesting to this audience, one of the things we were interested in is, do different demographic groups differ in how they view the world around themselves in terms of this valence, arousal, and dominance of the words, right? And we didn't want to fall into that familiar trap that some work has fallen into, where they say, oh, women give higher scores for words than men on average, so they must be more emotional. That's clearly wrong for a whole number of reasons, leave alone that different numbers. Your 4.6 might be the same emotionality as somebody's 3.7. So we are not doing that. What we are looking for are things like, what is the shared understanding within different demographic groups? And we found that there are significant differences. So for example, we found that women have a higher shared understanding of the arousal of terms. What does this mean? This means that if I give 100 words to women and I ask them to rank them by arousal, high arousal to least arousal, women themselves would agree amongst themselves way more or significantly more than men amongst themselves for the same ranking of words. In contrast, men seem to have a higher shared understanding of the concepts of dominance and valence. So men seem to rank dominance and valence. They have higher agreement amongst themselves compared to women amongst themselves. We also found things like if you're over the age of 35, you have a higher shared understanding of valence and arousal. If you're extroverts, you have a higher shared understanding of all 3 VAD. And even the paper also describes some other personality traits where we find these differences. So this was just very recent work, but it also actually raises more questions than there are answers, right? So why do these differences exist? To what extent should these differences exist at all? Are these differences that we ought to celebrate because different demographic groups are different, or to what extent are some of these differences a result of inappropriate sociocultural influences on the different demographic groups? So in summary, I'd like to leave by just highlight the 3 main points of this talk. And this might be a slightly controversial statement, but I think it's true. Machine learning systems that learn from human data have inappropriate biases. This is a good assumption for us to start with and immediately, or even from the beginning, try to deal with these biases rather than, oh, let's put a system out there and then let other people discover if there are biases and then let's deal with some sort of problem for that. The second point is that machine learning systems can be intentionally used to harm and manipulate, also as Graham mentioned, and we need work on how do we avoid this, how do we mitigate this abuse. And finally, of course, equity does not imply sameness. As I was saying, I think we need more work on measuring commonalities and differences across these demographic groups because A, we want to celebrate what is inherently a nice feature of the different groups, but also we want to track what are the causes of, are the result of inappropriate sociocultural influences. And so tracking that might be a way to look at what solutions can we have to prevent these inappropriate biases and what progress we are making in that field. All right, final note, all the resources that we've created, the lexicons and so on, and the data is all freely available for research purposes, and you can find them over my webpage, and I'll be happy to take your questions. Thank you.